Right, so in this question we have a crank and basically two pivot links. So third paragraph there says crank OA, which is 48 millimeters long. Okay, so that's important to note. The line from O to A is 48 millimeters long, because that's actually going to give us the size of the circle. It's going to be radius 48. Rotates in an anti-clockwise direction about point O as shown. Then link CB pivots about fixed point C. So fixed point means that C doesn't move position, but it's pin jointed, right? So it can pivot left and right around point C. And then we've got AB and CB are both 110 millimeters long, and they are pin jointed at A and B, right? So first things first, I'm going to start by drawing my crank. Now, the crank, we're told, is 48 millimeters long, or 48 millimeters radius. So I'm going to start with that. So a crank always moves in a circular motion. And I need to find point C as well. So it's out 115 and down 68. Okay. So in the question, this is point O, this is point C. Now, to get A, just go 30 degrees this way. So that's OA. And then we're told that the line from A to B and from C to B are both 110 millimeters long. So I need to get 110 millimeters on my compass. So we're not given the position of that, of those lines, or we're not given the position of B directly with measurements, but we're told that the lines from A to B and C to B are both 110. So I can swing 110 from A and swing 110 from C, and where they cross gives me point B. Now, in order to find point P, okay, you'll have to look at part 1 of the question. It says plot the locus of point P, which is the midpoint of link AB. So it's basically halfway along AB, so I could just measure across 55. Copy that. Now, so what we're going to have to do is basically this crank here is going to turn anti-clockwise. So we'll have to split that up and label it accordingly. And essentially, as this moves, okay, C is stuck in this position, so it can only move left and right, like my finger here. So basically, as this turns, it's going to drag B with it. So the whole thing is going to move in one smooth motion. So I'm going to split up my circle first of all. Okay, and we're told that it's rotating anti-clockwise, so I'm going to label that accordingly. So A is going to move anti-clockwise to this position first, so it's A1, then A2, A3, A4, A5, etc. C is always remaining at position C. Okay, so it's a fixed point, so it doesn't move position. Now, technically, because PC is staying here, and we know that B is going to move left and right, like so, we also know that this can also travel only along there. Okay, it can only travel in that circular arc. So by drawing that, it then means that I don't have to swing this every time. Okay, this can only move along that path because it's a fixed point at C. So technically this is another crank, okay, even though it says it's a link, okay, but technically because it's a fixed point here, but it tells us that it can rotate, this can only move in that circular arc. So B can only travel along that, which now means that in order to find my point for B1 and B2, etc., I'm just going to swing from here, and we know that it's going to have to be constrained to this arc. So B is always going to be along here, essentially. So A is going to rotate anti-clockwise up into A1. So I'm going to swing that, and I'll get a mark on here. Okay, so I'll just fill that in red first of all. Or in pink. So basically this is point B1 now. This is the line AB after it has rotated into position A1. Okay, now if I measure the distance from B1 or C to B1, it'll be the same 110. It has to be because it's on that circular arc. You can see there it's on my 11 centimeters there. So in order to find P on this, then what we do is we would measure, again it's just halfway, so it's always going to be halfway along that line. So I get position P1 there. And now to do, so I'm going to have to measure the length of AB again. So if you have two compasses, this becomes much quicker. You can do points B1, B2, B3, B4, etc., etc., and you can do point P all in the one go. So if I'm putting this in A2, B2 ends up on there. So that's B2. I'm going to join B2 to A2. So that's basically the line AB after A has rotated into A2 position. And again, we're going to have to measure halfway, so I might just do that with my set square this time. That gives me P2. And it's essentially just a repeated process then from there on out. So I've just done a couple more. Okay, I strongly would recommend that you do add some labels, because it's very easy to get mixed up in all the lines. Okay, so I'm not doing too many at one time. Just doing them as I go along. I could go along and just draw all the lines, but it might end up taking me longer in the long run. Yeah, I'm trying to figure out which line is which. Especially when it comes in here, when you've got a lot of marks for different points. It might be just easier to do them while you're here and it's fresh in your mind. once you've all your points, you can complete it with a free end curve. Alright, so that's the locus for point P. The last thing to do in this, so part 2 of this question was determine and indicate in degrees the maximum angle of rotation of link CB. Okay, so we said that CB rotates around point C along this arc. So basically they ask us, they want us to find out how far across this way and over to the right does it rotate. Now the furthest point that it rotates to the left, so was 0.6, which was here, and the furthest point over to the right was 0.11, which was in here. So if I join both of those back to C here, and then get a protractor, we can then measure the angle between the two red lines. So that's the furthest that it went to the left and the furthest that it went to the right. So put the point of the protractor right down the corner on C, line the line at the bottom of the protractor along one red line, and according to the protractor here we are at about 53 degrees roughly. So I'm at about 53.5 degrees, so I'm just gonna, I suppose if I'm more accurate, it's on 53 degrees, so I could just write in 53 degrees. Okay, and that's that part of that question finished. So that's 2018 question C4, and that's part A of the question.